Hello everyone, so this week we are going to be talking about counting, and I'm going to start off with accounting basics, the principle of inclusion and exclusion. So let's say that you have two integers, and I'll draw a number line here. You have two integers, a and b. So the number of integers between a and b, so in the set a and b, inclusive. So if it's inclusive, I should draw this. In this set here, inclusive, we have b minus a plus 1 integers. And then if we go from a to b, exclusive, we have b minus a minus 1 integers. And that's the number of integers between a and b. So I'll do some practice numbers. For example, from 3 to 5, and so we just have 4 in between. So if we're counting this inclusive, we're including 3 and 5 in the count. We can clearly see that there are 3 integers. So, but we would do this mathematically as 5 minus 3 plus 1, which is equal to 3. But if we calculate this exclusive, we will only have one number here, and that would be 4. And so the math for this would be 5 minus 3 minus 1. We only have one integer between the two. So this is applicable when we do our first problem. You were assigned even problems from 10 through 40 for tonight's homework. How many problems is this? So you have to do from number 10 to number 40. And in your math class, usually they assign you the odd problems because textbooks at the very end, they have the answer key for those. So you would usually you would see O for odd numbers, but number 10 to 40 even. So that would be 40 minus 10 divided by 2. That's equal to 30 divided by 2, which is equal to 15. But if you remember, you're also doing problem 10. You're not just doing, the problems that it takes to get from 10 to 40 divided by 2, because we're only doing the even ones. We're doing problem 10 as well. So that would be 15 plus 1 equals 16. Alright. I hope that made sense. Try to get an intuitive feel for why, this principle works. Alright, problem 2. The circumference of a circular table is 30 feet. If a set of silverware is placed every 30 feet around the circumference of a table, how many place settings are there? Okay, well, I love drawing diagrams. So this is our table, and there it has a circumference of 30 feet. And we want to have a set of silverware every 3 feet. And this is actually, kind of an obvious problem with an obvious answer, but I will draw it out just so it makes sense that this would be true. Well, first of all, we want to divide this into chunks of 3 feet. We want to divide, this circumference by chunks of 3 feet. So from here to here, we have 3 feet. And from here to here, and from here to here, and from here to here. And then that goes all the way around the circle. I'm not sure if my proportions are correct, but that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, my proportions were definitely not correct. But I'll just count the sections I have now. Here we have 1, 2, 3, 4, 5, 6. Okay, yeah. And let's just pretend that these two are smushed together. So we only have 10 sections. So this is just, section 1 will just be very big. Section, yeah. Okay, so this is what our table looks like right now. We have divided into 10 sections, the circumference, and each of those sections is 3 feet. So if we have 10 sections, and each are 3 feet, then in total we have 30 feet, which is what the problem stipulates. But now we want to count the notches here that represent, this the place settings. So if you were to count them, you would get 1, 2, oh, here, I'll just start this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which makes sense because 30 feet divided by 3 feet is equal to 10 spots for setting the table. Alright, so, oh nice, problem 3. In a science classroom, 19 students have a brother, 15 students have a sister, 7 students have both a brother and a sister, and 6 students don't have any siblings at all. How many students are in the classroom? So I feel like, personally, the best way to solve this problem is with a Venn diagram. So I would draw something like this. Brothers, sisters. So this column, this circle is for students who have brothers, this circle is for students who have sisters, and this circle is for students who have both. And then outside of that is for students who have no siblings at all. And we know in total, like all of these numbers, so this number here, there will be a 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 number outside. We know that all of those numbers added together will be the total number of students, which is 19. Well, we know first off that 6 students don't have siblings at all, so we can put a 6 here. And we also know that 7 students have both a brother and a sister, so we put that here. And so this is a good thing to know. 7 students have both a brother and a sister, and those 7 students are counted when you're in the 15 students who have a sister and the 19 students who have a brother. So this circle in total adds up to 15, and this circle in total adds up to 19. But that doesn't necessarily tell you what the numbers are in here and here, because this section, this number here, and this kind of chunky, like this circle with a chunk bitten off, this is for all the students who only have a brother. So they have a brother, but they don't have a sister. And that's important to note, because this is for students who only have brothers, and this is for students who only have sisters. But this is just any student who has a brother. So those students may also have a sister, and we don't know. But we know that there are 7 students with both, so we can figure out what's in here and what's here. So 19 minus 7 is 12, and 15 minus 7 is 8. And if you add all of these numbers up, 19 students, we don't know the total, sorry. The 19 was for the students who have a brother. We're trying to find how many students are in total. Whoops, I misread. But now we have a Venn diagram here. We can add all these up and figure out how many students there are in total. So we have 12 plus 8, which is 20, plus 7 plus 6. 7 plus 6 is 13, so we have 33 students in total. And that's how you would solve this with a Venn diagram. So you have to remember, the students with both siblings, with both a sister and a brother, are included in the count for both the students with a sister and the students with a brother. So they're counted twice. So you can't just add 19 plus 15 plus 7 plus 6, because you're counting the students with both a sister and a brother twice. Or, well, at least multiple times in this count and in these 2 counts. Alright, problem 9. What am I saying? I'm a little bit frazzled today. Problem 4. At the pound there are 40 dogs. If 22 dogs have spots and 30 dogs have short hair, what is the fewest number of dogs that can have short hair and spots? Alright, so this time they gave us the total. And we're trying to find the number of dogs in the middle of, in the intersection of the 2 circles. So we have these 2 circles. This one will be a circle for the dogs with spots, and this will be the circle for the dogs with short hair. We know that there is 40 in total. And we know that there are 22 who have spots and 30 dogs who have short hair. So this will add up to 22. And this will add up to 30. So I'm going to actually give these variables, call this A, B, and C. And we also know that there are dogs who have neither short hair nor spots, so I will call that D. Well, we know that A plus B is equal to 22, and that B plus C is equal to 30, and that A plus B plus C plus D is equal to 40. Alright, so what we want to do is minimize the number of dogs that are in between. So, well, first of all, we're counting 2B twice. We can substitute A plus B, so we have 22 here. And then we know that C plus D is equal to 40 minus 22, which is equal to 18. And then you can find the difference between A and C here, or of C minus A, I suppose. No, A minus C. So A minus C, and the B's cancel out, is equal to 22 minus 30, which is equal to negative 8. So you have this right here. And then if you add these together, you get that A plus D is equal to 10. A plus D is equal to 10. So actually, wait, forget all of this. You just need to find you just need to maximize the number of dogs that are here and here. Don't worry about number of dogs who are neither, because we're already over. So the number of short dogs is equal to 30, right? And we want to minimize B. So, and then you have, okay, wait, 30, you have 30 plus 22, which is equal to 52. So we are already over our limit of 40 by 12. So 52 minus 40 is equal to 12. So 12 of these dogs must be both. I thought this was like a minimizing problem, but no, there has to be 12 dogs that have both spots and have short hair, because otherwise you would be over your limit of 40 dogs. So if you have 12 here, then you have 10 here, and you have 18 here, and that adds up to 12. That's 30 plus 10 is equal to 40. So 12 is the only number of dogs that could have spots and short hair. Alright, so problem, I'll save problem 5 for the next video. That concludes our first 4 problems and the basics of counting.